Hi everyone, this is Subnet Zero and welcome to my channel. So just to give a little recap on what we did yesterday, we focused on how packets travel via a router, okay? So a simple explanation was that, any package, it originates from your laptop, it flows through the router and it goes to the endpoint, okay? And also in the specific packet, any packet, but this one example of a packet, it has the destination address as well as the originating address, like an envelope. And this router is like a post office, so it will ensure the packets are routed properly to the correct end destination. So this is the simple example of how packets travel in a router, in a single router, okay? Now that this concept is clear, let's escalate this to a slightly higher complexity, and let's focus to how packets travel via multiple routers. So before we dive deep into this concept, I need to make one thing very clear. A packet does not travel in a straight line always. Yeah, I know. This is mind boggling. My mind boggled too when I first got introduced to this concept. But packet does not always travel via straight line. What do I mean by that? Let's get into the practicalities of this, okay? Mhm. Let's look at the diagram. This is the originating computer, this is a packet, this is router A, and this is the end destination, okay? Now normally what we think that an originating packet is a lot of times, but not always, goes from the originating computer, and then it goes to router A, and then it goes to the end destination, right? This is like the standard operating way a router works, but not necessarily always. Let's say if a packet is originating from this, a packet is emerging from the originating computer, and if it's going through A, but what if there is a network issue or some problem with it? So if it does not go, then what? It does not mean that all network or travels will stop, because if that was the case, completely a lot of failures would happen, and we cannot afford to have failures, especially during production environment or any or any working environment. So instead, let me first remove this, remove this. Yeah. So instead, what happens is that we will, yeah, when I use blue, just remember that means the correct route, okay? So instead, the originating packet will go to router B, from router B to router C, and from router C to end destination. Similarly, if let's say this also fails for whatever reason, we have another backup, which is the packet will go to router D, and router D to router E, and from router E to end destination. Okay. Now you will be having the question of why. The big question as to WHY. Why? Why do we have this? Because a single network route, it might clog, there might be congestion, there might be router failures, there could be 100 other things where it might fail. But just because if this one path fails does not mean things should stop working. That's why we have alternate paths through which the packets get routed. And this is why we say that the internet is like m- like multiple routers are all interacting with each other to ensure there is like if there is one clogging somewhere, so at least it has multiple ways of traveling. Yeah, I hope this is clear. And yeah, we will move to the next video, and I hope this was easy and simple to understand. Also, for your reference, this is what a router looks like. Okay, this is an ASUS router. This is what it looks like. That's why I made the diagram the way it is. It's like this. Okay. So I hope this was easy. This was simple to understand, and I'll see you in the next video. Okay. Bye.